So today we're going to be finding equivalent forms of polynomials, and the main thing we have to remember from Algebra 2 is how to factor. And you guys did a lesson, just a review lesson on factoring, but you might need a little extra refresher. I don't know. But two of the types of factoring you're going to have to do is the sum and difference of cubes. You guys remember that from Algebra 2? Okay, so I pretty much use the same rule for the sum and difference of cubes. So what I always tell my students is just find each cube root, which in this case would be a and b, and then bring over the sign. Right, then you're going to square the first one, change the sign, multiply them together. The last sign will always be a plus sign, and then square the second one. So that's the rule for the sum of cubes. And difference of cubes, basically the same thing. You find each cube root and bring over the sign, square the first one, change the sign, multiply them together. The last sign is always a plus, and then square the second one.
What was in the second root?
All right. I'm going to do a couple of examples of each one. Now, it's very possible that on the AP exam, you'll have to be able to do this and not have a calculator. So that means it's probably a good idea for you to have the perfect cubes memorized, probably to like 7 cubed. It would help you a lot. But we're not going to do any that are crazy large. So this example, we have x cubed plus 27. So you do need to recognize that x cubed is a perfect cube, obviously, and so is 27. So what is the cube root of 27? What times itself 3 times gives you 27? 3. So we find each cube root, bring it over with the sign, and then square the first one, change the sign, multiply them together, and then plus, and then square the 3. And then almost all the time, this will not be able to factor further. So this trinomial cannot factor. The only time you would be able to do it is if it was like x to the 6th, and we're not doing any of those, not today anyway. All right, let's look at another example of difference of cubes. So we're going to have 8n cubed minus 1. Now, the one thing that people forget is that 1's a perfect cube, a perfect square, a perfect everything. So 1 times itself a million times, it's still going to give you 1. What about the cube root of 8n cubed? 2n, good. So we have 2n minus 1. And then be careful, when you square 2n, that you square the 2 and you square the n. And then 1 squared is just 1. All right, so hopefully you guys remember that, or it's coming back to you pretty fast. All right, we're also going to need to be able to factor by grouping. And most people remember grouping really well, actually. So our example over here by grouping is going to be x cubed minus 4x squared minus 9x plus 36. All right, so when you're factoring by grouping, there needs to be 4 terms. So hopefully that'll trigger something in your brain that you need to factor by grouping. And you divide the terms into 2 groups that have 2 terms. So you can do it with brackets. I usually just use like this dash line, but however you want to do it, it doesn't matter. Yes, miss.
Is this supposed to be up from exponent, or is that because of what your computer's doing?
Oh, is it doing something weird? Let me fix it. There you go. Thank you. All right, do you guys remember what to do?
Greatest common.
Okay, we're going to factor the common factor out of each group. So our first group, we're going to factor out x squared. Now be careful on the second group, whatever sign is here, that has to come down. So if it's a minus sign, you are going to have to factor out a negative or it's not going to work out right. All right, so what number do I need to factor out for our common factor? 9. Good job. So we're technically factoring out negative 9. And then for this to actually work, these need to be the same. If they're not the same, then something's wrong. Either it won't factor by grouping or you did something wrong. So they are the same here, so that's good. So our final step in grouping is not going to be our final step in factoring, but our final step in grouping is to do 2 sets of parentheses. Do you guys remember what goes in these? What you factored out, and then what they have in common. So what you technically did is factored out a common factor of x minus 4. Okay, now we are not done. What else can we do to factor this? Difference of squares. X squared minus 9 is the difference of squares. And to factor the difference of squares, you find each square root, and you put one with a plus, and you put one with a minus. So a lot of times today, after you factor by grouping, there's another step of factoring using the difference of squares. All right. And then the last 2 examples are going to be using quadratic methods when it's not a quadratic. So the first one, we're going to have negative x cubed plus 5x squared plus 14x. So when you look at that, what do you think if you're going to be factoring? Greatest common factor, which is going to be an x. And also, if this leading coefficient is negative, you want to factor out a negative. It's just going to make your life a lot easier when you start factoring. So we're going to factor out a negative x. Right. And then we're just going to factor this trinomial. And so depending on who you had as a teacher last year, they may have worded this differently than I do. I don't know. But basically, when you're factoring, what you put here and here needs to multiply together to give you whatever this is. So to get x squared, it's just going to be x and x. Do you remember what this tells you about your signs? This minus? They're either going to be the same or they're going to be different. Different. So if this is a minus, your signs in here are going to be different. 1 plus, 1 minus. And then what you put here and here needs to multiply to give you 14, the negative 14. And then because the signs are different, basically subtract to give you the 5. So what do y'all think? Multiply to get 14 and subtract to get 5. Mm-hmm. Which one needs to be negative so we get a negative 5? The bigger one, which is 7. Good job. So that's it. All right, one more and then we'll move on. So the other example with quadratic methods is going to be a quartic. We have 2x to the 4th minus 5x squared plus 3. Does this one have a common factor? No. All right. So I'm going to do the same thing. It's slightly more challenging for 2 reasons. One reason, we have a 2 here instead of just a 1. The other reason is this is x to the 4th, which is kind of weird. So what we put here and here needs to give you 2x to the 4th when we multiply. Good. We're going to have x squared and x squared to get the x to the 4th. And what do I need to do to get the 2? One of them needs to be a 2. Good job. All right, this time, this is a plus sign, which means these are going to be the same sign. What are they going to be? Negatives. Good job. And then what we put here and here needs to give you 3. And there's only 2 choices. It's going to be 1 and 3, one way or another way. And then when I do this and this multiplication, that's going to add to give you negative 5x squared. So take a second and try and figure out where you put the 1 and where you put the 3. So when you do this multiplication, you're going to get negative 5x squared when you add. All right, so did you guys put the 3 with the 2 parentheses or in the other one? With the 2, yeah. Good job. So that's going to be negative 2x squared. That's going to be negative 3x squared. And they definitely add to give you negative 5x squared. Are we done? We're not quite done. X squared minus 1 is the difference of squares. Now we're done. Now it's possible your Algebra 2 teacher taught you something like where you, I can't remember what it's called. Bottoms up, maybe. Does that sound familiar? Nobody? Okay. Well, maybe you didn't. Good. All right. So let's talk about the standard form of a polynomial. All of these problems that we just started with, they started off in standard form. In standard form is when the terms are in descending order. And there's no parentheses. It's just term after term after term in descending order from the highest power to the lowest power. Now, what the standard form tells us really nicely is the end behavior. Because it's super easy to be able to tell the degree and the leading coefficient if they're positive or negative, or if the degree is even or odd. So that's nicer when it's in standard form. And the constant term, so the very last number, tells you the y-intercept. Which is nicer than when it's in factored form, because if we had to plug in 0 and do some multiplication, it's just easier to do in standard form. And then the factored form sometimes is called intercept form of a polynomial is really nice also because it tells you the zeros and their multiplicity. And it's really easy to see that from the factored form. All right, and then I have a little terminology note. A few lessons ago, we talked about relative extrema and absolute extrema. There are other words that sometimes they use in place of those. So I just want you to see them both. I'll try to use them both. But relative extrema are also called local extrema. And then the absolute extrema are called global extrema. And just one thing to keep in mind, and this is going to come up on one of our examples, is that the global extrema occur at the relative extrema or at the endpoints of the interval. So sometimes you just have part of the domain that you're using, and that very highest or very lowest a lot of times occurs at the endpoints. Okay. So let's do some examples. These first two are kind of review. So, and you guys did great on your quiz with the limit notation. I can't think of anybody that wrote it wrong, which is great. If we want to describe the end behavior for the for the right side, we're gonna do the limit as x approaches infinity. But some of you still were a little confused about answering this question correctly. But if it's the right side, you just look at the leading coefficient. If it's a polynomial function and that leading coefficient is negative, it's going to be going to negative infinity. All right, and then a couple people in here were confused about the same and opposite. When you're deciding if the left is the same or opposite as the right, you look at the degree. If the degree is even, it's the same. If the degree is odd, it's the opposite. I think some people were comparing these to see if they're the same. I don't know. I was just a little confused. All right, and then the y-intercept is going to be when x is 0, and when it's in standard form, it's just the constant. So what is the constant on this one? 0, good. And then our zeros and our multiplicity we're gonna need a factor to find those. So we're gonna write this in factored form or in intercept form. What would you guys do first? We're gonna factor out a negative. And what's the greatest common factor here? Good job. Factor out a negative x squared. Right, and then we're just going to factor this trinomial by doing x and x, different signs. And then we want to multiply to get 6 and subtract to get 1, or negative 1. What do y'all think?
2 minus 3.
Good job. All right. And once we get that, it's just the same stuff we've been doing by looking at these factors and telling the zeros. All right, so if this is a factor, what is the 0? 0. And what is its multiplicity? Good job. Right, and then the others, they're just linear factors, so we'll just do the opposite, and they both have a multiplicity of 1. All right, any questions on this? All right, this next one is new for you guys to do without a calculator, I'm fairly sure. We are going to identify all the intervals where the function is less than 0. So when you think of something that's less than 0, what do you think? What numbers are less than 0? Negative numbers. So this is either going to be negative, where the function gives you a negative. On a graph, like on the coordinate plane, where would it be graphed? The function be graphed if it was less than 0? Above the x or below the x? Below the x. So there's two ways you can think of this. I'm going to show you two ways we can do it. I have a feeling it's going to be easier for you just to do a little sketch, but I'm going to show you both ways so you can decide. So let's just start off with us doing a sketch of the graph. I'm going to have to move up a little bit and draw it. So we are just going to label our zeros on this. And then we're going to use the end behavior and the multiplicity to get just a little sketch of this graph. So the only one that's going to have something interesting, I guess, happen on the x-axis is 0, and it's going to need to bounce. And then on this graph, both of our arrows are going to be pointed down. So it's going to look something. Well, I didn't do the best graph, but something like that. It doesn't go straight down. It's still kind of going over. All right, and so if we were just looking at the graph and trying to decide where this function is negative or where this function is less than 0, it's going to be these sections where it's graphed below the x-axis. And we're just going to give those answers in interval notation. So there are going to be 2 intervals. All right, so let's start with the first one, the one farthest to the left. what should the first number in the interval be where it starts being below the x-axis? It's going to be from negative infinity to negative 2. Right? What about the one on the right? 3 to infinity. Now, someone in my last class got a little confused, and it's common. She said it's 3 to negative infinity. Negative infinity is never going to be on the right side of an interval because the right side is this bigger number. Negative infinity can never be the bigger number. All right, any questions on that? Okay, let me show you the other way. The other way is to use a sign chart. Now, we do this a lot in calculus, and we'll do it again in here whenever we start doing a different type of function. So on the sign chart, we need to put in our zeros that we just found. Right, and so we want to know by plugging in values where we're going to always get a negative. Now, the reason we put a 0 is because that's where the graph would change from positive to negative. It would have to be at a 0. And so what we do is test a point in each region. So we'll start with a number on the left side of negative 2. Now remember, we're doing all this without a calculator. And so with a calculator, we would never have to do this. You could just look at the graph and be done in 5 seconds. So without a calculator, it's very doable. It's just a little bit time consuming. So I'm going to take negative 3 and just kind of in my head, I'm going to put it into the factored form. So if I put negative 3 in for this x and I square it, and then there's a negative in front, is that going to give you a positive or a negative? We square the negative first, and we get, yeah, that's definitely going to be a negative. All right, if I put negative 3 here, am I going to get a positive or a negative? Negative. And then what about here? Negative. All right, so a negative times a negative times a negative. Is that going to give me a positive or a negative? Negative. All right, so we have to do that for every region. So we would put in negative 1. So I'm going to put in negative 1 here, square it, and then multiply by a negative. What's that going to be? Negative. Every time I put something here, it's going to give me a negative because when you square something, it's positive and then multiply that by a negative. So that, in this case, in this problem, that first factor is going to be negative every time. All right, what about if I put negative 1 here? Positive. What about if I put negative 1 here? Negative. Good. So this is a negative times a positive times a negative. What is that? Positive. Negative times a negative. Okay, I might have said it wrong. Okay, so you guys try to do this for yourself. So try just in your head to plug in 1 and then plug in 4. And I'm going to go ahead and tell you that first factor is negative no matter what you put in. Right, and then your answer regions come from whatever gave you negative, because that was what the problem was looking for. And it's the same exact answer that we got using the graph. So it's up to you. Why did I use parentheses instead of brackets on my solution? Why are these parentheses and not brackets? There's a reason.
The line doesn't end.
Well, the infinity and negative infinities have to be parentheses no matter what. But the reason why the -2 and 3 have parentheses is because this didn't have an or equal to. So keep that in mind. If it's less than or greater than, use parentheses. And then if I have the or equal to, you're going to use the brackets. Okay. And then on E, I actually saw this question when I was making these problems either on a practice test or from AP Classroom or something, and I thought it was something I should bring up. So E says, between which two zeros should F have a global maximum? So I drew it appropriately. You might not have, it's fine. So do you think that the highest point should be between -2 and 0 or 0 and 3? Why? You're right. I don't know who said that. Why do you think logically? I mean, I drew it that way, but why do you think logically it should be higher between 0 and 3? I can't hear.
Beyond that, it's just always counting down.
It has to do with the distance between the numbers. And so since there's a bigger distance between 0 and 3, there's that maximum is actually going to get a greater height. Because a greater length gives or will attain a greater height. Okay, we still have, that was just one example. On the back, we're actually going to mark out A. After I did it, someone asked me a good question last period, and she was right. And it's just, we're going to mark out A. It'll be fine. We don't know enough about limits to really do A the right way yet. All right, so for number 2, polynomial function is G is given by that. And this one has a domain that we're only using this function between -7 and 7. That is important. In a second. Not quite yet, but it will be. All right, so we're going to skip off on A, but we are going to do B. What do you guys think the y-intercept is of this function? Good. You just get the y-intercept from the constant value. All right, we are going to find the zeros in their multiplicity again. Because this one has 4 terms, we are going to factor it by grouping. All right, and then after you factor by grouping, it is still going to have a difference of squares in it. And each one of these zeros is going to have a multiplicity of 1. All right. Now to answer D and E, I think we need to have an idea of what the graph is going to look like. Now this one, we are only going from -7 to 7. We're not going to continue in both directions. And I know my zeros. And I did mark out A just because it doesn't really make a lot of sense for this particular problem. But on the left side of this graph, should it be like really, really low or should it be really, really high? What do you think? If I was going to do the end behavior, if it didn't just stop at -7, would the left side be at negative infinity or at positive infinity? The left side? I'm doing it in the opposite order. The right side is going to be positive infinity. The left side should be the opposite, negative infinity. So this graph, it'll say starts really, really low, goes through, crosses at -12, goes through, and then really, really high. I can't get a super accurate graph, but it's going to stop at both of those points. It would not curve like that. It would just keep going up. I'm just going to run out of paper. So yes. All right. So how many local extrema do you guys think? 2 local. Sorry, I keep hitting that. Little hill and valley. All right. And then what about the global extrema? Where are they going to be? Or what x's are they going to be at? -7, 7, the 2 endpoints. So it's super easy just to glance over those endpoints, and then when you see a question like E, just say it doesn't exist. So I'm going to try to give you guys more and more of those. This is easy to just forget about them. Okay, 3 and 4 shouldn't take too long. So number 3 is a cubic graph. Is it kind of special? It's a little special. Are those both cubes? Yeah. So we're going to factor it using the difference of cubes. Do you guys know the cube root is 64? 4. Now, like I said, almost all of the time that's not going to factor. So when we find the zeros, one of them is fairly obvious that one of the zeros is 4. The other one is a lot less obvious. And since it won't factor, we're going to go ahead and use the quadratic formula. So the opposite of e plus or minus the square root of b squared minus 4ac divided by 2a. Now, when you guys are doing these on your own, if you want to just use your calculator to figure this out, you can. We can do it by hand. It's just going to take some time I don't really have right now. That is going to be -48 underneath the square root. Okay, so if there is a negative underneath the square root, what do we have to do? Pull out an I. Good. And then we can start thinking about that as positive 48. And what perfect square, or what's the largest perfect square that divides evenly into 48? There's 2 of them that do it, actually. The largest. Simone's whispering is 16. 48 is 16 times 3. Okay, and then we're going to take the square root of 16 and get 4, so that's plus or minus 4i square root of 3 over 2. And then your last step is always to draw this little heart, and it has to include all 3 numbers that aren't under the square root. If you can divide through by everything in that heart, you would divide, so it reduces to that. That's 2 imaginary zeros and 1 real zero. And that's going to be the case. If it's the sum or difference of cubes, you're going to have 2 imaginary and 1 real. All right, are you okay? It's a lot of algebra there. Okay, and then for C, we want to write the complete factorization of H using only linear factors. So one linear factor we already know from when we factored it is x minus 4. The other two are going to come from these imaginary zeros. So it's going to be x minus, and then in parentheses, negative 2 plus 2i squared root of 3. And then x minus negative 2 plus 2i squared root of 3. I know that looks weird. That is what they're wanting you to write. It looks a lot better like we wrote it on A, but those aren't. X squared plus 4x plus 16 is not a linear factor. Yes, ma'am.
So if you write it twice, should it be negative 2 minus 2i on the second one? Or is it supposed to be the same?
It's supposed to be the same. So the difference is it's oh no, you're right. Thank you. Yeah. One of them's a plus, one of them's a minus. But both of them are minus in front of the parentheses. All right. Any other questions? Class, she's paying attention. All right, this last one, we're going to multiply this out. Now, I don't think this year that we've actually practiced this algebra skill where we multiply binomials together. And so we can only multiply these together 2 at a time. So which 2 do you think are going to be smartest to multiply together first? Anybody have an opinion? The i's, yeah. Let's definitely multiply these first. There's a couple of reasons. When we multiply that and simplify it out, we're going to get rid of the i's, which is just going to make it easier to work with. But those are also special binomials. And so if I multiplied it all out like using double distributive or do it using FOIL, whatever you want to call it, what's going to happen to our outer and our inner if I multiplied that all out? What would you get if you did negative 5i times x and then positive 5i times x? What do you get when you add those? They cancel. It's always going to be 0, and that will always be the case. So what I tell my students to do is shortcut FOIL or shortcut double distributive, where when it's like this, they are the same terms, just a different sign in between, you can just do the first and the last. Now, if you do it all, it is okay. It is not going to be wrong, but we can do shortcut, where we're just going to do x times x, and then negative 5i times positive 5i is going to give us negative 25i squared. Do you guys remember what I squared is? Close. Negative 1. So I is the square root of negative 1. I squared is just negative 1. So what is negative 25i squared? 25. All right, so now we're ready to multiply it all out here. So we'll multiply x times x squared is x cubed. I'm going to do this a little out of order, just so I don't have to rearrange. I want my next term to be x squared, so I'm going to do negative 3 times x squared. And then I'll do x times 25 and negative 3 times 25. And there it is, all multiplied out. All right, and then the last part of this question is to tell the zeros, the x-intercepts, and the y-intercepts. So the zeros, I'm just going to look at the factored form and just give the zeros as 3, negative 5i, and positive 5i. Are all of those x-intercepts? Are i's x-intercepts? No, so just the real number. All right, what about the y-intercepts? 0, negative 75. Good job. All right, I know that was a lot in one day. Depending on how much you remember from Algebra 2, that may have felt very overwhelming. I don't know. So I'm going to give you guys your assignment.